Question 31. The diagram shows a measuring cylinder used to measure the volume of a small stone. What is the volume of the stone? Well, here I hope you can see at the beginning the volume looks like it's 18. That's without the stone. And after it looks like it's 26. So the volume of the stone is 26 minus 18, which is 8. So the answer is A. Question 32. A heavy beam rests on two supports. The diagram shows the only three forces F1, F2 and F3 acting on the beam. The beam is in equilibrium. Which statement is correct? Now, very often students will pick A because they know that upward should equal downward, but what they do here by saying all forces are equal in size, well, let's just imagine F1, F2 and F3 were 10, because that's basically what you're saying when you pick A. Well, if all of them are 10, that means the total force up the way is 20 and the total force down the way is 10. So they get confused by this. Okay, now what they mean and what they don't really, they're not able to articulate here is upward should equal downward and clockwise moment should equal anti-clockwise moment. That's why the answer isn't A. The answer is in actual fact C. Question 33. The mass of an astronaut is 70 kilograms on the moon. What's the mass of the astronaut on the Earth? It's exactly the same. His mass will not change, only his weight does because the gravitational field does. Okay, so mass will be the same. Question 34. Four objects are each acted on by only two forces as shown. Which object is in equilibrium? Now you're looking for equal and opposite forces, so the answer is B. Quite often students will ask, well, why is it not D? Whilst they are equal, they're not directly opposite. In D, the object will turn. In fact, it will turn in a clockwise direction because you've got a bigger force up the left and a smaller force down the right. If you imagine I had a ruler, for example, if I had a bigger force up to the left, up the way, and one going down the way, then the thing will rotate. Whereas in B, the forces are directly equal and opposite. So the answer is B. Question 35. The diagram shows the speed time graph of a car. Which area represents the distance travelled while the car is accelerating? Well, the car's only accelerating in the first part in the triangle X. So the distance is the area under the graph, which means that it's A. The distance for the entire journey would be X plus Y, and the distance while it's travelling at a constant speed would be Y. But whilst it's accelerating, it's only area X, so the answer is A. Question 36. Two distance time graphs and two speed time graphs are shown. Which graph represents an object that it is at rest? Well, the answer here is B for ball. Now, A is showing as a constant speed. C is showing as a constant acceleration. D is also showing as a constant speed. But because in B it's distance against time and the distance isn't actually changing, it means the object's not moving. So the answer is B for ball. Very often students get confused with speed time graphs because they are looking at the shapes and not the y-axis and x-axis as well as the shape. Now by shape I mean a horizontal line, I really should say trend, a diagonal line, a curved line. You need to also focus on what the y-axis and the x-axis is saying. The x-axis is always going to be time, so ultimately you need to focus on the y-axis. Speed against time and distance against time and acceleration against time, they all mean different things. Question 37. An object moves at a constant speed for some time, then begins to accelerate. Which distance time graph shows this? So constant speed is here on the distance time graph, and then it accelerates, it's curving up the way. The answer C. Students might pick A, and A would have been correct if it was a speed time graph and not a distance time graph. Many people found this quite difficult to understand. The answer is C. Question 38. 4 different model steam engines each lift 1 kilogram object from the same laboratory floor to the same laboratory bench. Each engine takes a different time to lift the object. How does the most powerful engine compare with the other engines? Well, basically the work done is going to be exactly the same, because the height you're lifting it to and the mass and therefore the weight that you are lifting, work done equals force times distance, is exactly the same. However, if you're lifting it faster, then the power is bigger, because power is work done divided by time. So if work done equals force times distance and power equals work done divided by time, then power equals force times distance divided by time. Now the mass is 1, so the force is 10, because that's the weight of the object. Distance we don't know, but we know it's the same distance. And then here it's talking about whether it's faster or slower. In other words, is the time less when it's faster? And the time is longer when it's slower. So what's the answer here? Well, work done is the same, but if it's faster, then the power is greater. So the answer is B. Question 39, also a tricky one. 4 people of equal weight on a beach use different routes to get to the top of the sea wall. Which person produces the greatest average power? Well, they've all got the same mass and hence they've got the same weight. You're looking for the person to get to the top the quickest. Okay, so whatever route they take is irrelevant. It's who gets there the quickest, because ultimately against their weight they're doing the same work regardless of route taken. The answer must be C. Question number 40. A force F moves a load from the bottom of a slope to the top. The work done by the force depends on the size of the force and the distance moved. Well, remember what I told you, you're looking for the force and the distance to be in the same plane. So if you had the weight here only, then the distance you're going to use is P. But because you've got a diagonal distance and a diagonal force, it's F times R, so the answer is C. I hope that was helpful.